So let's continue with example C here. We're going to create a confidence interval for the amount of wake time for patients treated with a drug to treat insomnia. So the data we need to collect from this problem would be this summary statistics, sample mean, sample standard deviation, sample size, and the fact that we want a 95% confidence interval. Well, the fact that we're asked for a 95% confidence interval gives us a little direction in statdisk. So let's go there. We're going to go to analysis, confidence intervals, mean one sample. We've got summary statistics, not raw data. If we had raw data, we'd use this tab over here. But our summary statistics for our 95% confidence level are that we have a sample size of 23, sample mean of 81.3, the sample standard deviation S was given as 22.7. Now it's important to realize that we were given S, that we don't know what the actual population standard deviation is. What's the notation for the population standard deviation? Not S, but what is it? What Greek letter?
Sigma.
Sigma. So if you're given sigma, that would change things. And after this example, we'll go see how that would change things. But for now, I think we got everything we need. So you can click evaluate. And we get a margin of error. And I'll write that down here. Error is 9.82, we'll call it. Our confidence interval is 71.5 is less than mu is less than 91.1. Keeping in mind that we're treating insomnia, we can state this about our conclusion. We can be 95% confident that the true mean wake time is between 71.5 and 91.1 minutes. So your conclusion should be roughly like that. Again, please don't mention anything about probabilities here. These aren't probabilities. We have a certain level of confidence in our procedure, but once you actually have the numbers, it's no longer a probability. How are we looking on that part?
Good. Good.
Now let's see here. I think there's another little piece of this that we got to look at. And I'll admit this can be a little tricky when you're reading these problems, especially when we do some of our work later on. So our confidence interval was between 71.5 and 91.9 minutes. And the follow-up work on this says, where is it? What does this suggest about the mean wait time of 104 minutes before the treatment? So before people were treated, they had a mean wait time of 104 minutes. After they were treated, we came up with this as our confidence interval. So what does that suggest about the treatment? Did the treatment have any effect?
Yeah.
It appears the treatment helped reduce the time.
Yeah, it appears the treatment was effective, right? I mean, our best guess is that it reduced it by almost 23 minutes, right? But it's probably somewhere in here. as the true mean level of wake time. So yeah, you're making a substantial improvement in the mean amount of wake time. Yeah, and that's because this is not part of the confidence interval. Are we good with example C here? Anything else you'd like to follow up on? There is one thing that I want to follow up on, and that is this part right here. So the population standard deviation is one of the things you could put here if you know it. Now, I've already commented in the first video that we did today that it's unlikely that you would know the population standard deviation and yet somehow not know the mean. But let's take a thorough look at all this. This should be something that's on your handout. Let me go down here. There we go. So when you're creating a confidence interval for a population mean, basically you have three choices. The first choice reflects the case where you don't know what sigma is. So if sigma is not known, but you have a normal distribution, or sigma is not known and you have a sample size greater than 30, then you'd use a t distribution. Under what cases do you use a z distribution? That is the standard normal distribution. That's this right here. Well, in that case, you'd have to know what sigma is and either have a normally distributed population or a sample size of greater than 30. Now, they put for you in this little table that it's rare that you would actually know what sigma is. And that's true. It'd be weird to know what the standard deviation is, but yet not know what the population mean is. If neither one of these apply, then you're just going to have to use a non-parametric method or a bootstrapping method, neither of which we're going to cover. Actually, we're not going to cover bootstrapping at all. Non-parametric methods get covered at the end of this course. So how does that play out in terms of some problems? Well, let's take a look here. And we'll just do a little preview of a problem that you're going to get in your homework. I think it's problem number 7. Yep, perfect. Assume that we want to construct a confidence interval. Do one of the following as appropriate. Find a critical value from a t distribution or a z distribution, or state that neither the normal distribution nor the t distribution applies, meaning that you have to use a bootstrapping method or a non-parametric method. We want a 95% confidence interval, sigma is not known, and the normal quantile plot of the 17 salaries of basketball players on a team is as shown. So let's work through our little list of possibilities here. So the fact that sigma is not known tells me or rules out one possibility. I'm not going to be working with the z distribution. What else do I know? Well, I've got 17 salaries, so that's not a really high number of salaries. Let's look back here at this little table here to try and choose between t and z. We've eliminated the z distribution. It's not going to be that. We don't know what sigma is. We're okay there. But our sample size isn't greater than 30. So that doesn't apply. Does the data come from a normal distribution? Well, let's look at that. Here they gave you a normal quantile plot. Does the data look like it comes from a normal distribution?
No.
No. So that's not true. If that's not true, and this isn't true, then you're stuck with a bootstrapping or non-parametric method. that would be your answer for something like this. So neither of those applies. Cool. Hey, nice work. Let's take a look at another one like that. Any questions on the previous one before I move on to another one like this?
No.
All right, going once, twice. Let's try another one like this. Assume that we want to construct a confidence interval. Do one of the following as appropriate. Find the value of T sub alpha over 2 or Z sub alpha over 2, or state that neither the normal distribution nor T distribution applies. So on a 90% confidence interval, sigma is not known, and the histogram of 58 players' salaries in thousands of dollars is shown. All right, let's run through our little list of options again like we did with the last one. And let me get rid of a few things here. Okay. So what'd they tell us about sigma?
It's not known.
It's not known. Thank you. So that eliminates one of the possibilities here for us. It's not going to be a Z distribution. Well, could it be a T distribution? Let's find out. Well, we don't know what sigma is, and we've got 58 members of our data set. So that means that n is greater than 30. If we don't know what sigma is, but n is greater than 30, then we can use a T distribution. So now that the job is to figure out, well, what T distribution we're going to use. So I'll call this example D. I want a 90% confidence interval, and n equals 58. If I have a 90% confidence interval, then what's alpha?
0.10.
Yep, 0.10. If I have 58 items in my data set, what's my degrees of freedom?
57.
57.
57, excellent. So what I need now is T sub alpha over 2 for the appropriate degrees of freedom. Or in other words, T sub 0.10 divided by 2 for 57 degrees of freedom. 0.10 divided by 2 is 0.05. So this is what I need to find. If you'd like to take a look at what that is graphically, let me remind you. I'm looking for the point on the T distribution with 57 degrees of freedom with 5% of the area in the right tail. This is always going to be the area in the right tail when you use this kind of notation. So 0.05. How do you suggest I find this? No suggestions?
Statdisk.
Yeah, statdisk. Analysis. Probability distributions. Student T distribution. And there you go. Degrees of freedom is going to be 57. Now the question is, which one of these do I put something into, and what should that something be? Am I going to put in a T value and find an area, or put in an area and find a T value?
0.05 for the area.
0.05 for the area. And that's going to be 0.05 in the right tail. So the area to the right is 0.05. And there's your t-value, 1.672. Are you okay with how we found that?
Yeah.
Yeah.
Now, if you actually knew what sigma was, then you'd have to find a z-value. So if you had to find a z-value, then you could use norm inverse, or you could use statdisk as well. But if you had to find a z-value, the z-value would actually be pretty close there. So probability distributions, normal distribution. The difference is that you'd have to work with the area to the left. The t-distribution, the way it's set up in statdisk, works with the area to the right. If this was a z-distribution, the area to the left would be 0.95. And you'll see that it's actually pretty close to what the z-value is. Oops, 0.95. 1.64485. So pretty close. And that just reflects what we've seen before, that the t-distribution looks more and more like the z-distribution as the degrees of freedom gets larger. So, okay. We're looking okay with that little foray into T versus Z versus bootstrap? All right. Let's do one last example here. So we'll do example D here. And let me see if I can't paste the data for you into the chat. Oh, there we go. So the data set's in the chat. Let's practice working with that. So listed below are the student evaluation ratings of courses where a 5 is excellent. The ratings were obtained at one university in a state. I hate that about the book online, is that they strip away anything remotely interesting. All right, sorry about my rant. Construct a confidence interval using a 95% confidence level. What does a confidence interval tell us about the population of all college students in the state? All right, well, let's go back to statdisk. You're going to want to click statdisk online to get back to the data editing menu or the sample editor. Now, if like me, you've got a bunch of data that's already there, click the clear key to just clear it all out. And then you'll paste it in like that. Now be careful when you're pasting in some data. statdisk is not going to like any names. So if you have some names, you're going to have to delete it. This one, fortunately, doesn't have any names in it, so we're okay. Is everyone able to get the data in all right?
I didn't get the data.
I didn't get it.
Oh, did it come through in the chat?
Did you? I didn't see it.
Oh, you know what? That's because you guys aren't in the waiting room. I sent the data to everyone in the waiting room. My bad. There you go. Did that come through now?
Yeah.
Yep.
All right, good deal. While you're pasting that in, let me remind you that we're going to find a confidence interval for the ratings in a course. Student ratings. Did that paste in okay for you?
Yeah. Yes.
Yes.
Sometimes people have problems when they paste it in, it pastes out sideways or it pastes into all one cell, and you just got to play with it. Maybe copy it into Google Sheets or someplace else, and then try repasting it.
Okay, I'll try that because mine did all in one cell.
Yeah, so maybe try putting in Google Sheets and then copy it from Google Sheets and then repaste it.
If you click the number 1 and then it highlights the whole row, and then I'll paste in the row if that helps
Oh.
anyone.
Hey, that's good news. So in case you missed it, click the number 1 and it highlights this row. And then when you paste it, it should paste into one column.
Trying it right now.
All right. Holding my breath. Any luck?
It's not letting me paste anything. I don't know
Really?
what the deal is. Yeah, maybe I thought I copied it. Let me check again.
Okay.
I'll figure it out.
All right. Well, let's take a look at the analysis then. Analysis, go down to confidence intervals.
Oh, there we go.
Good deal. Mean one sample. This time, as opposed to what we did last time, we're actually going to use the data. So click the Use the Data tab. And we want a 95% confidence interval. The column that contains our data is column 1. And clearly, I don't know what the population standard deviation is, so let's just click Evaluate. Yay. So we got a confidence interval of 3.6 to 4.3. So sample D, 3.6 is less than mu, is less than 4.3. Now again, you've got to state your conclusion in words. So I'll give you a minute to state that in words, and maybe try and hit me up through the chat, see what you write. So at least I can see what you write and then critique it. So you should have something like this. We can be 95% confident that the true mean rating of a college professor is between 3.6 and 4.3. And as I've said, I kind of really want to see that word true in there. True, and then a description of what parameter that you're working with. Most of you seem to do really, really well on that. So let's work on the second part of this question. What does this confidence interval tell you about the population of all college students in the state? So it says state, select the correct answer from the choice below, but we don't have those choices. The question is, what does it tell you about all students in the state? Their confidence interval and their rating. Does it tell you anything about other students?
No, it's just on the one university.
Yeah, because, you know, this one situation is not representative of all college students. You have students who have chosen to take a particular course for whatever reason. It's a particular professor, and it's at that institution. There's no reason to suspect that that would be typical of all college students in a particular state. It's not going to be representative. That's the big problem. So basically, it tells you nothing. You can't generalize this beyond that one particular professor for that one semester. All right. Looking good on that one, I hope. Any follow-up or comments on example D here? All right, we'll stop things here.